Safety is a primary concern whether it is at school, at workplace or at roads. So, keeping the road safety in mind, government is all set to make airbags a compulsory fitment in all cars in coming years. Airbags are very important equipments as they inflate immediately when hit by a hard surface. Do you know from where the gas comes to inflate the airbags? Well, there is an interesting chemistry behind this. Airbags contain sodium azide, which decomposes into sodium and nitrogen gas by absorbing heat. This nitrogen gas inflates the airbag. Can you predict what type of chemical reaction is this? Well, it is a decomposition reaction. Let's know more about it. Decomposition reactions are the reactions in which a compound breaks up to form two or more simpler substances. Just think about it once, how a compound which is stable can decompose? Using a hammer or some sort of energy or what? Well, for a decomposition reaction to occur, heat, electricity or light energy is required. Since it requires energy, or we can say that energy is absorbed, these types of reactions are called endothermic reactions. The decomposition reactions where heat energy is required are called thermal decomposition reactions. Let us now take some examples. Let's begin with the decomposition of ferrous sulfate, for which we require burner, boiling tube, spatula, and ferrous sulfate crystals. Take a small amount of powdered ferrous sulfate in a clean boiling tube with the help of spatula. Heat the boiling tube on a low flame using test tube holder. Now observe the tiny water droplets near the neck of the boiling tube. Also, the color of the salt changes to white. Keep on heating the boiling tube. After some time, you will see that white colored solid changes to a brown colored solid. This brown colored solid is ferric oxide. Now smell the evolved gas by gently wafting it towards your nose. You will observe that the gas smells like burning sulfur. Here, one substance, that is ferrous sulfate, is splitting up into three substances: ferric oxide, sulfur dioxide, and sulfur trioxide on heating. So, this is a thermal decomposition reaction. Let us demonstrate one more experiment to enhance the understanding about decomposition reactions. For the decomposition of lead nitrate, we need burner, boiling tube, spatula, and lead nitrate. Solid lead nitrate is white in color. Take a small amount of lead nitrate in a boiling tube. With the help of test tube holder, heat the boiling tube on a burner. Observe the changes carefully. The color of lead nitrate is changing from white to brown. You can see that a brown gas is coming out from the boiling tube. This gas is nitrogen dioxide and it is a poisonous gas. Bring a glowing splinter over the mouth of the boiling tube. We will see that it catches fire and starts burning again. It shows that oxygen gas is also evolved during decomposition of lead nitrate. Remove the boiling tube from the burner. You will see that the brown color of the salt fades away and the intensity of the brown gas also decreases. On heating the boiling tube again, the color of the salt changes to brown and the intensity of the brown fumes of nitrogen dioxide also increases. Here, one substance, that is lead nitrate, is splitting up into three substances: lead oxide, nitrogen dioxide, and oxygen on heating. So, this is a thermal decomposition reaction. Another important example of thermal decomposition reaction is decomposition of calcium carbonate or limestone, which results in formation of calcium oxide and carbon dioxide. Let's now quickly move on to an example where electricity can cause the decomposition of a compound. Yes, you heard it correctly. Electricity can also cause decomposition of water into simpler components. This is known as electrolysis of water. Electrolysis refers to the usage of electricity for decomposing a substance. In the given chemical equation, water is breaking down into hydrogen gas and oxygen gas when electricity is passed through it. Let us understand the process of electrolysis. The apparatus required for performing the electrolysis of water is called the Hofmann's voltmeter. The Hofmann's voltmeter consists of 3 joined upright tubes. The inner tube is open at the top to allow the addition of the electrolyte, which is the acidified water. The 2 outer glass tubes are connected to a platinum electrode. These electrodes are connected to the positive and negative terminals of the battery. The electrode connected to the positive terminal of the battery is called the anode, and the electrode connected to the negative terminal of the battery is called the cathode. When the electric current is passed through the water, it dissociates into hydrogen ions and hydroxyl ions. Observe the slow evolution of the gases. At the cathode, the positively charged hydrogen ions get discharged as the hydrogen atoms that form the hydrogen molecules. At the anode, the negatively charged hydroxyl ions are discharged that form water and oxygen gas. Each of the 2 gases displaces water and gets collected at the top of the 2 outer tubes. Now, observe the volume of the gases released at the 2 electrodes. You will notice that the volume of the hydrogen gas released at the cathode is double the volume of the oxygen gas formed at the anode. However, how will we confirm that the gas released at the cathode is hydrogen gas and the gas released at the anode is the oxygen gas? In order to find out the answer to this question, collect the gas formed at the cathode in a test tube and close the mouth of the test tube with a cork. Label the test tube as C. Similarly, collect the gas formed at the anode and label it as A. Take the test tube C and bring the lighted matchstick close to the mouth of the test tube C. A pop sound proves that the gas in the test tube C is hydrogen. Now, take out the test tube A and bring the glowing splint close to the mouth of the test tube A. The ignition of the glowing splint proves that the gas in the test tube A is oxygen. So, the compounds can be decomposed by heat or electricity. Sunlight is also a form of energy. Can it also cause decomposition reaction? Yes. When a compound such as silver chloride is placed in the presence of sunlight, it decomposes to silver and chlorine. Decomposition reactions are important for us. These are used in black and white photography, extraction of metals, and manufacture of calcium oxide.